All right, let's go ahead and get started. So today we're going to cover testing and continuous integration. So we're going to look at a couple different types of testing. We're going to look at API testing, which is more of like, when I hit this route, do I expect the right HTTP status code, and do I get back the right response? So it's kind of a little bit more similar to the manual testing you're doing with Postman. So you make that request and you just quickly verify by eye to make sure everything's okay. So we'll kind of automate that, and then we'll also look at another type of testing called unit tests, which allow us to dive kind of more at like a function level. So if we want to just test specific functions to make sure if I pass in this thing into a function, I get back this result. In our specific case, we're actually just going to write a few unit tests to cover like the different model validation cases. So that's what we're going to look at today. And then we're also going to hook this up to something called continuous integration, and we're going to use a particular type of continuous integration service called Travis. Also, continuous integration, you'll hear me, a lot of people just say CI for short, so that's the acronym for continuous integration. So we'll hook this up to Travis CI so that this way, whenever we make a push to GitHub, it'll run all these tests, or Travis will run all these tests for us, and we'll be able to determine if these tests pass, then we can put this in our master branch. If they fail, then we don't put this put the code into the master branch. So it's a really good workflow, and it's a pretty common workflow you'll find, just because before you start putting everything in master, which is generally like what you ship to production or what you deploy, you want to make sure that branch is stable. So you kind of run all these tests. With any new code, you add a bunch of tests, and if everything passes for your new features and for existing features, so to make sure you didn't break anything, if that all passes, then you can merge that into this master branch. So that's kind of like the workflow, what we're going to look at and do. So before we get started, next week we're going to have a guest speaker on non-relational databases, also called like NoSQL. So there's a lab just to do a little bit of research. You'll type this up in like a Google Doc and just do your own research to learn a little bit about the different types of databases. In this class, we looked at SQLite, which is a relational database. And one of the main reasons I use SQLite is just because it's so easy for each of you to have your own databases, and you guys can mess it up. You can easily create new ones. If you destroy it, you can just, it doesn't really mess up anything. So it's really nice. But generally, like for applications that I make with like Laravel, Node, I usually use something like MySQL, which is also a relational database. But next week we'll look at, I think the guest speaker will cover MongoDB. So it's a NoSQL database. So you can kind of learn a little bit about the differences between those two. Maybe, we'll see. Maybe not, because that person doesn't have like Camtasia, so I'll have to ask. Yeah, usually I have Camtasia and everything installed, so it might not. So you want to make sure you come. That might be a good incentive to get people to come. It's not recorded. Let's see. Okay, so this should be your last assignment. There's one on testing in CI, so you'll kind of do it for an endpoint that you're for a previous lab. And then one thing I added to the final project requirement, so it was TBD for a while, the part 3, but I filled it in. So it's basically the testing and CI aspect to it. So you'll go in and add a bunch of tests for that API you create in part 2. So once you read, you can read through this after we go through today, and it'll probably make more sense. But otherwise, now the requirements are complete. Okay, so if you want to go back to the SQLized code base that you worked on, so in that video lecture when we covered SQLized, if you followed along, open that one up. If you don't, you can actually clone it, and I can just pop the link into the general chat. Let's see. Okay, so I put that in class demo. So if you want the URL, just clone that repository and then npm install inside there so you can get it running. And I'll give you a minute to do that. And I'll just go ahead and open this up with Atom. And let me close everything. Okay, so we're going to look at a few different tools today. So the first thing that we're going to look at is something called Frisby.js, and this is kind of a nice, easy library for doing those API types of tests. So I make a request to get/post. I make sure I get a 200 back, and I get an array of posts back. So something like that. So it's very high level, automating what you're doing manually with Postman. We're also going to use another library called Chai. And so, well, actually, let me give, I'll cover this a little bit later. But, okay, so if we look at our package.json, this just contains a list of dependencies to get the app running. So now we're going to install dependencies that are specific just for testing. And so that actually goes under another key called dev dependencies. And to install these, we can say npm install. And the first one we're going to install is Frisby. And we're going to say --save-dev. So if you run this command, it's going to create another key in that package.json under dev dependencies. So if we look at that, we see dev dependencies and Frisby. And the reason there's a separation between the two is just, some packages are just for development, like the testing, and others actually run when our API is in production. So there's that distinction. Okay, so we're going to install two more things, and we'll kind of go through what these are as today progresses. The next one is we're going to install Jest, and we'll save this as a dev dependency. And this is a test runner, so this will actually allow us to just run these tests that we write. So Frisby is kind of like just the thing just for specifically testing the API. So it kind of makes a request to an endpoint, and you can kind of verify like the response and the status code and all that. Jest will allow us to run the tests. And then one more that we need to install is another one called Chai. So we'll say npm install chai --save dev. And Chai is an assertion library, so it allows us to say, I want to check to make sure this equals this. So for example, if I want to do like, if I had a function called sum, and it took two numbers and it added them together, I want to verify when I call sum with 1 and 2 that the answer is 3. And so it kind of just checks, two values to see, are these equal? That's like the most basic assertion, but there's a lot of different assertions that Chai offers. Okay, so those are the 3 different dependencies. They're all installed in dev dependencies, and you should be good. Okay, so let's write our first test. So Jest is the test runner, and it expects a folder called __test__. I don't know why they decided to do that as opposed to just like the word test, but for whatever reason, that's what it is. Kind of the default. I'm sure you can change it.
Well, to make it more unlikely that you'd ever call something that.
Maybe. Yeah. Most of the time from what I've seen, it was just like, it's just called test. But this is kind of like the first time I've really messed around with Jest a little bit. So it's, yeah, kind of weird, but. Okay, so it's up to you how you want to organize things. I'm going to create two folders. I'm going to create one called API, so these are like those API tests. And then I'm also going to create a folder called unit for unit tests. And we're going to just start off with just the API tests. Okay, so if we look at our app.js file and just look at some of the endpoints, let me collapse each one of these so we can kind of get a high-level overview of all of them. Okay, so I think a nice simple one to start off with is the get a specific track. So we can say, if we look at this endpoint, we ask for a single track resource by its ID, and if it's successful, that gets returned in the JSON. Otherwise, we get a 404. So we can write two different types of tests here. One to verify this case, and another to verify this case. So I'm going to go inside the API folder and create a new file. And I'm going to call this track-test.js. It's really up to you, kind of like what convention you want to follow. Some people call it spec. They say like track.spec.js or track.test.js. Or you don't even need the /test. It's really up to you, kind of like what organization method you like to call it. Okay, so let's start writing our first API test. So the first thing I'm going to do is pull in Frisby into this file. So I'll say require Frisby. I keep typing like Frisky by accident. It's like my cat's name, so I might do that. Okay, so with our test, we can use this it function, and it takes two arguments. The first is a description, so what is this test doing? So we can say, generally it starts off with kind of like the phrase should something. So when you run these tests, it'll say it should, and it'll kind of like reads nicely. So I'll say it should return a status of 200 when the track is found. And so the second argument is a function. And then here I'm going to say return Frisby. And I'm going to make an API call to the endpoint. So I'll say http://localhost 8000/API/tracks/5. And so Frisby, it's actually, well, sorry, I made a mistake. It should be Frisby.get. So I want to make a GET request to this URL. And then I can chain a method called expect on here. And I can say expect the status, so the HTTP status code, to be 200. And usually I kind of like to break these up onto multiple lines just because as opposed to having a really long line, just put each method on its own line, but it's up to you. So this is our first test. So let's go ahead and run this. So if we open up terminal, should I do this? Okay, so how do we run this? So there's a command line utility that Jest installed when we installed Jest, and it's in there. Well, If you're to look in here, it's actually, like if I scroll down to, let's see, Jest, H-I-J, here it is. Jest bin jest.js. So we can actually run this specific file. And so the way we do this is we can say so from my current directory, node modules bin, jest /bin, and then jest.js, and then give it the file name. So in this case, I can say __ test API, and then track test. Now you can give it the file name and it'll run that specific file, or if you leave off the file name, it'll just run everything inside that __ test directory. So kind of depends. Like if you have a big test suite and some of them, if it starts taking like 20 seconds, then you might want to just target very specific files. So it's kind of good to know about that. Okay, so right now we're getting an error, and it's saying fetch error. It tried to make a request, but it failed. Anyone want to take a guess why? Yeah, server's not up. So let's go ahead and start this up. So I'll say nodemon and then app.js. Okay, so once we get that, we can just hit up and run it again. And we can see one passed. So you can see right here where it kind of spits out that description. It says it should return a status of 200 when the track is found. And just so we can see it actually error, not because of like a connection error, but to check like maybe I got the code wrong. If I say 201, let's rerun this again. And you can see test failed. If I scroll up a bit, expected value to strictly equal 201, but it received 200. So we can see that assertion working there. Any questions? Sure. Anything specific in here?
What you typed originally.
Oh. Like the test command?
Yeah.
Oh, here, I can paste that inside the chat. Okay, so, oh yeah, question?
Not supposed to fail. Why now?
It shouldn't fail as long as you have the server running and you ran, yeah, and you had the command correct. Because track 5 should exist, and meaning our endpoint should return 200.
I can't see, so I typed in test.
Oh.
Thank you.
Yep. Okay, so if we look at this endpoint, so we covered kind of this condition in the if statement. We should also check to make sure, if we send it to a track that doesn't exist, we get a 404 back. So let's go ahead and copy this test and just kind of rephrase this. I'll say this way we have coverage over both sections. So we should say it should return a status of 404 when the track does not exist. And then we'll change this to 404. And then for the tracks, maybe I'll just do something like -1. I know there's no record with an ID of -1 in there. All right, so let's go ahead and run this again. And then we can see we have the one test suite, meaning the one file, and then 2 of our tests passed. Now, generally, I like to see every test fail at least once. So if anything, I'll go in here and just change this to 400, run it to make sure there's no sometimes you might get a test might pass for a reason where your code is actually broken. So it's good, I think, just a good practice to see, just make sure you see it at least fail once. There's another practice for doing these types of tests called test-driven development, where you kind of write your test first before you write any actual code. So, if you write your test first and run it before the code exists, then you'll at least see it fail once. But we're kind of going after the fact. It's kind of I would say, kind of a little, more advanced workflow, because you gotta write your test first and get into that habit as opposed to writing the code first. So, but here, yeah, we're kind of writing the test after the fact. So it's good just to kind of check to make sure, hey, is this correctly verifying our code? So we see it failed. We kind of scroll up. We see HTTP status 400 does not equal 404. So that looks cool. So I'll change this back to 404. So I saw it fail at least once. Any questions? Okay, so let's write another more complex test. So if we pull up this API and go to 8000 API/tracks, let's see, actually. Okay, so I just kind of verified that the status codes were cool, but it's probably also a good idea to check the JSON. For example, this API returns a name and a list of playlists. So let's kind of check to make sure this general structure exists. Okay, so we're going to write another test, and we'll say something like it should return the track name and its playlist. All right, so I'm going to copy out the first part where I just make the get request to track/5. And now I want to expect or write an assertion that says, hey, is this name Princess of the Dawn? So I'll copy this out. And the way I can do this is the expect function takes in a couple parameters. So I can say the first one is JSON. It has a name attribute, and its value is Princess of the Dawn. All right, so let's go ahead and run this again. Okay, so it looks like it passed. So if I just throw an extra character in here just to purposely make it fail and rerun it, and I scroll up a bit, okay, so you can see there's my spelling mistake. Okay, so we check the name. Let's also check to make sure that it has its playlist. So we kind of got this piece. Now let's check its playlist. So I can say expect, and there's a few ways you could do this. You can kind of go through each one and check all the attributes, but sometimes verifying all the specific data makes your test a little brittle, just because if you change that data in the database, then your test is going to fail, right? So a nice way of verifying that this exists, you could just quickly say, hey, is it an array? Are there IDs and names for each object in this playlist array? It's kind of more general, so if the data changes, then your test still passes, and it's still a good idea to see if your API broke or not. So we can say JSON types, and they have like a Frisby has this special syntax where you can say playlist.star. So the playlist is that key in our JSON, and we can say for each object in there, I want it to have like this general structure. So I'm going to say expect, oops. I expect it to have an ID, and Frisby has this this other kind of library bundle with it called Joy, and so we can pull this in at the top. So we can say Joy is equal to Frisby, and so we're using that destructuring. So just as a refresher, you could say like const Joy is equal to Frisby.joy. Keep typing join. Using that destructuring syntax, you can kind of shorten it and just say joy once, but these two are essentially equivalent. So we can pull in joy, and we can say for the ID, it has to be a joy dot number, and it's required.
Wait, join or joy?
Joy. I keep typing join because it's in a sequel. And then we also expect it to have a name attribute of joy.string, and it's required. So now we're just saying, hey, each object, it has to be these types for each one, but other than that, like that's all that's required. Yes?
Sorry, what was the playlist.star again?
That's just saying this is that array, right? Because if we looked at our endpoint, playlists, it's this. It's an array, and it's saying like for each, like a special syntax they have. Also, if we look at our API, because we're just saying response JSON, and we give it like the eloquent, or sorry, not eloquent, the Sequelize collection, it kind of spits out this extra information, which generally I would not put in the API. Like, it's not useful to a consumer, so why expose it? It just happens to get automatically serialized. So I think that's something else we could handle, but that's why I'm not writing assertion for this, because I think the only pieces that I think that would be valuable would be these two pieces. So if we were to clean up our API a little bit and delete this, our test would still pass because ID and name are the only things that we really care about, and at least in exposing in the API.
Is it required or required?
Required, yeah, thanks. Yeah, this approach is also, or this like syntax is useful for like if I did get/tracks or get/playlist and I get back an array, you can verify against that array response as opposed to checking like each individual property. Okay, so let's run this. And it passed. So we can kind of make this fail by saying, let's say if the name was, instead of saying a string, I said number. We can see what the error would look like. If I scroll up, we can see validation error, child name fails because name must be a number. So let's put this back as string. We run it, and we get it passing. Any questions? All right, so the gets are the easy ones. Let's do the post request. So we'll do post and delete, and I think for the lab you'll do footer patch. Okay, so let's make another test. So I'll say new file, and I'll call this artist-test.js. So I was just kind of picking this convention based on like the resource name. In this case, the resource is track. So you can have a file per resource or API resource, but up to you how you want to do it. So we have an artist resource, and if we look at our endpoints, we have artist ID. So we have a get for a single artist, and we also have a post for API artists. So let's write endpoints against these. So I'm going to copy out the Frisby call, put this in here, and we'll say it should create an artist. Okay, so we'll say return Frisby, and this is a post request, right? So if we look at our app.js file, we make a post request to API/artist. So the URL will be http localhost 8000/API/artist. And so in this post request, we want to send the payload, right? The data to create the artist. And so that becomes the second argument to that post method. So we can pass it in as an object. And then we could say name ITP or whatever you want. So when I make this post request, I expect a status of 200 and then I also expect, so if you remember from this API, or even if we look at the call and we expand this a bit, we say artist create, we pass in the name, and then we say response JSON artist, so the created artist. So that artist will contain the name property that we sent. So I want to say expect the JSON to have a name property of ITP. So you guys remember, like with the post call, what gets generated on the server and sent down as a response in kind of like when you're creating things? What's like new? What new piece of information do we get back when we create some type of model?
Like an artist ID?
Yeah, artist ID, exactly. Yeah, so when we create it, right, typically a database will have like an auto-incrementing ID. It creates it, and then we would have access to that in our JSON, but we don't know that kind of when we make that request. So there's a few ways we can go about this. We could kind of look it up and try and figure it out. I think that gets a little complicated and makes our test a little harder to read. So it's also, I think something that's sufficient is we can just say, hey, do we get back an ID and is it a number? That's kind of sufficient. So what we can do is use that JSON types, kind of like what we did in the last test. And we want to see if the ID is a joy.number. And we'll say it's required. And so we need to kind of pull in that joy function or object from Frisby. So put that at the top. And this should be sufficient. Any questions? Okay, let's run this test. So I'm going to clear just to kind of move it back to the top of the screen. And instead of just running track test, I could run the artist test file, or I'm just going to run all of them. It's still relatively short because we only have like 4 or 5 tests. So we'll just run Jest.js, and this should just run everything. So it looks like it passed. Let's change this up, and I'll say instead of ITP, we'll just add like some other character in there just to see it fail. We'll run this. We see it fail. And we can see that the assertion is essentially what we expected, the expected failure. So let's delete that error. We'll rerun it, and everything's good.
I'm using the wait async file because I like wrote over it.
Oh yeah, that's fine too.
And well, I failed this test just because it said the async callback was not invoked within the 5,000 millisecond timeout. So I got like a timeout error.
Maybe you've hit like a certain path that caused it to fail. I'm not. Yeah, I wouldn't know for sure.
Yeah, it said that the test took like 5.8 seconds, so it automatically failed it.
I'm guessing because maybe like the server didn't respond. So maybe you've hit a path in one of your routes where it didn't respond. So we'd have to probably look at it a little bit more closely. So another good test that you might want to write for, I'm not going to do it now, but is a validation test. So if we look at our app.js file and we look at this post request, right, we're just testing this case. So this highlighted piece. But it's generally good to also do this. And this might actually be your lab, I forget. But making sure that you get back a 422 or whatever for the code, and you get like an array of errors and all that kind of stuff. Okay, so I'm going to minimize this. Let's do a delete request. So we're going to test this API delete playlist. And so this one has a handful of past and interesting challenges. So I think in this case, for deleting, we want to verify the happy path, which is, hey, can we delete a playlist resource? So do we get back 204? Everything's good. Or do we get back 404? So meaning that playlist didn't exist. So I'm going to create a new file, and I'll call this playlist-test.js. And I'm just going to copy out that Frisby import and put that at the top. Okay, so I think we're going to start off with the 404 case because that one's actually pretty easy. So we're going to say it should return a 404 if the actually when deleting a playlist that does not exist. So here we're going to say return Frisby dot, and then there's a function called del for delete. And this is http://localhost 8000/API/playlist/ and I'll say -1 because I know that it doesn't exist. And this one we expect the status to be 404. All right, let's go ahead and run this. Okay, so also up here, it kind of gives you a good idea of the files that were ran, so you know if your file was included in the test run. So playlist looks like everything's okay. Now let's do the kind of sort of the success case. So I'm going to copy out the 404 one and paste this, and I'll just change these numbers. So to 204. All right, and I'll just pick a playlist, so I'll say 6. And I should probably change this description. It should return a 204 when deleting a playlist that exists. And before we actually run this, let's just kind of look up the playlist. So playlist /6. All right, so this audiobooks one. So let's run this. Okay, so everything passed, so that's cool. So the one interesting thing about this is if I run this again, now it fails. Anyone want to take a guess why? Yeah.
The playlist no longer exists.
Yeah, no longer exists. And so there's a few ways we can deal with this. And so like I think what Laravel does is they actually use SQLite for testing, and they have this, there's like another version of SQLite that keeps it all in memory. And so before every single test, it kind of runs these migrations to create this database that's empty or even seeded with some data, and then runs it against that and does it for every single test, so that every single test has the database in the same exact state, which makes your test very predictable. With Node, we don't really have this infrastructure like out of the box, so we would have to kind of create that ourselves. And so you could kind of look into tools to do that. I think the simplest example would be, well, when I was kind of doing this, I think the simplest case for like the projects and even just for today is we will, whenever we run the entire test suite, or all the test suites, we will just reset the database. So every time I kind of run this command, let's just reset it. And the way we can do this is if we go to, let's see, package.json, we're going to add in another key here. So we're going to add that scripts block. And we're going to add a command called test. And so as opposed to running this Jest command directly, we're going to run it through this test command. So I'm going to copy out this and then paste it right here. And so to run this test command, you can actually just do npm and then test. So we're just aliasing it through this. But now, given that we're running it through here, this is like running it from the command line. So this is this gives me a way to kind of run like a terminal command or a bash command. So what I can do here is, if we actually go back to the command line, the way, if I do git status, right, this is a git repo. I've been running these tests which modify this database. If you run git checkout and then the database name, oops, I spelled that wrong. If I run this command, this will essentially just recheck out the file and wipe it out. So if I run that and then say git status, you can see it wiped that away. So I'm going to run that command right before and after every single test. So I'm going to say git checkout chinook.db semicolon. So this time, so whenever I run the test, it'll just kind of make sure it starts off from a fresh state. It's not a perfect solution, but it's, I think, the simplest and the one that's good enough for projects and today. But yeah, highly recommend checking out like Laravel's test suite and seeing how they do it, because they do a good job, but they also had to put in that effort to set up the infrastructure. Yes.
You mind going back to the artist? I'm getting like a
Yeah, I can paste this in the chat, and then
should create an artist. This returning says failure status is 200. So I don't know what that means.
yeah. What was the error?
Oh, sorry?
What was the error?
It says, so it shows like the console for that one, for the artist test. It says, it gives me a JSON response with an ID and the name that it should be. And it also says failure status 200, but it's saying that it's failing. So maybe I just typed it wrong.
Okay. Yeah. Let me paste this in here, and then you can kind of compare the two, and if not, we can look at it in lab. Okay, so now that we're kind of just rechecking out the database, we're kind of relying on Git to do that, so kind of handy. So we'll just run npm test. All our tests pass. If I run it a second time, wait, let me see something. So when I did this at home, I just did this right before and after, like recheck out the database, and I think that may have been it. Let me double check this works. Let me see what I did. All right, let me comment out this delete one to see if this is just messing things up. Oh, it's the create.
Is it because we can't create multiple artists of the same name?
I don't think we put that restriction on this, because let's see. If we look at artist, the name, there's nothing like saying the name needs to be unique. But let's see, it's returning. Let's see, it should create an artist. All right, I'm just going to comment out this piece, and if I can get it consistent, then at least with the other endpoints, then I'll look into that later. Okay, so npm test with everything but the creating an artist. Yeah, they see the ones that modify data, they get tricky. All right, let me look into these two later, but so let's see. Okay, so the two that mess with the database are deleting a playlist and creating an artist, but the other ones are pretty much, they shouldn't modify it, so it should be fine. Okay, so we'll kind of move on, and then I'll come back to it later. Okay, so I'm going to go back to package.json. I don't think I need this. So really just, even though we're not modifying it, we'll just keep this so it kind of resets it on each test, and then we run the test command. Okay, so let's see. Okay, so let's write a couple of the other types of tests. So unit tests. So API, good, high level, right? Just to check to see if our endpoints work. But if you want to test like more specific things, you could do that at the higher level, but maybe sometimes it's easier and your test will execute faster if you do it more at like a function unit level. So if you think about like for each of these tests, making these API tests, each one just takes a little bit longer than if I were to say like run a single function. So it's like a trade-off. So it's kind of up to you like how you want to test some things. And like I think the API tests with Frisby, it's good for a high level. Just check to make sure, hey, do these endpoints like roughly work? And then if I want to check very specific things like validation errors and see, like I think for example, we had the artist, right? And we have 3 different validation rules for the name attribute. If I want to check each one of these things, you know, I could do this at the API level, but if I were to do this for every single model and every validation, our tests, our entire set of tests would just take longer to run. And ideally, you want to keep them very quick, just because, like, imagine you're doing a project and you have multiple team members and your code base gets really big. Every time you make a change and you want to like put it into master, you kind of run through all these tests and it takes a really long time, right? And then it just that's like one reason. I can like one project I work on right now. I mean, it's kind of a pretty big front end app, but we have a lot of tests and it takes about 15 minutes just to run through all of them. So if you can find these little areas where to make them quick, unit tests kind of help do that, but you can only use, I would say, like unit tests are good for certain things, like functions, right? You want to test a function, you give it some input, and you get back this output, and just checking that, really good for unit tests. And I think the validation rules kind of fall into that category too.
What kind of tests would you run for front end?
Yeah, same thing. Instead of like, well, we have the unit test for testing like little functions here and there for our JavaScript, and instead of like the API test, we have something equivalent where it's sort of like in a way, visits a browser, checks things on the page, right? So asserting against the DOM to see if like this a validation error message exists and it has the class like error, so it's red or something. Like, yeah, like at work we use Ember, and Ember kind of has this all built into it, so it just allows you to like write these types of high-level tests, and it's still relatively quick as a so yeah, it's all kinds of tests. All right, so in the unit folder, I'm going to create just another folder called model, or maybe I should actually call it models. So you can imagine in my project, you know, we have a directory for models, but you might have other folders for like utilities or services or just other things, or working with APIs, and so I'm just going to break it out similar to that style. So inside the models directory, I'll create a new file called artist-test.js, so for that specific model. And we're going to write a handful of tests against this. So I'm going to pull in that artist class. So artist is equal to require. So from my current directory, we need to go up 3 folders into models/artist. So we're pulling in that specific model. And then we're also going to pull in that chai library. So chai has this assertion called expect. So we can say like expect this the result of this function to equal 1 or something like that. So it equals require and then chai. So I'm going to write a test, and let's say the name, right? So the name, it should be at least 2 characters. So we look at, let me close some of these. If we look at the artist file, right, we have a length validation rule, and so it needs to be between 2 and 10. So we're going to write one test to make sure that it fails when it's less than 2 characters. Okay, so I'm going to say artist is equal to new artist, and we can pass in a name of just 1 letter. And so we can run validation on this SQLized model right here by saying await artist.validate. So there's that validate method. It runs asynchronously. So given that we have to, you know, do this asynchronously, we need to tag this function with async. And if it fails the validation, it's actually going to throw an error. So kind of like what we did last week where we had that try catch block. We're going to move this into a try catch block. And so if this fails, we're going to catch the error right here. And so I'll just spell this one out. So put error. And this is where we're going to write our assertion. So we're going to say, let's check to make sure that the validation message says name must be between 2 and 10 characters. So the way this looks is we can use that expect function from chai, and we can expect the error.errors 0, get the first one, and then pick off the message. And this is all kind of like in the SQLized docs, or even if you just kind of like console log out the error, you'll see like you can find the message in the error that gets thrown. And we expect this to equal that message right there. Okay, so let's just run the unit folder just so you can see how fast they are. If I were to do node modules, Jest, bin, Jest.js, and we're going to go into the test folder and then the unit folder. So I'm just running the unit test. So it looks like it passed. Now if I were to like intentionally fail this, let me just kind of like throw something on the end of this and rerun it. And I scroll up. Okay, assertion error expected this to equal this, and kind of highlights. Well, here's that, yeah, my spelling mistake. Okay, so I have this file called artist test, and looking at it, I mean, right now I'm just writing a unit test just for, you know, these validation rules, but you can imagine for a model, I would probably have validation rules for a lot of different attributes, and I could kind of break it up saying like name should be at least, and just have them all this way. There's another way we can kind of like organizing it. We can organize it using these functions called describe. So I can say describe, and I can say name, and then I can put my specific test in this describe block. So I could have like multiple describes, and maybe each one target a different attribute. So it's just like another way of grouping tests. You don't have to use them. Yeah, it's kind of useful. And you'll probably see a lot of other like tests libraries use it, or you know, if you hop on a project that has existing tests that uses these particular technologies, you'll probably see this too. So, okay, so let's run this again, just so you can see like what happens with the describe block. And here you can see it says name should be at least 2 characters. So you'll probably see kind of multiple attributes depending on like how many describe blocks you have. Okay, so let's kind of copy this test, and we're going to do for the other bound, so the 10 characters. So it should fail if I make this 11. So let's do A, B, C. Cool. So that's 11 characters long. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah. Okay, so it should be less than 10 characters. Okay, so we'll go ahead and run it. So it should be at least 2 characters, and it should be less than 10 characters. So you can see each test and how quick it is. It's 16 milliseconds and 9 milliseconds. If we're just to go and let's run the entire test suite again, and we'll run npm test, just so you can see like how long the other ones take. Let's see. Oh, it doesn't spit it out. Oh well. Okay, so let's write the test for maybe one other. We'll say, I'm actually just going to copy this. It should contain only letters. So this will target the is alpha rule. So we'll copy this message here. It says name must only contain letters. And I'll paste this here. And to make this throw an error, I'll just throw in like a number. So we'll put in 2. All right, so we'll go back. We'll just run the unit tests. Okay, so they're all passing, so it looks good. Also, another thing that we can do is we can actually nest describes within describe. So if we're to look at this, we see just name, right? But it would probably be good if it said like artist name or something. So we could actually take this entire thing here, and I'm going to cut it, but I'll say describe, and I'll say artist, just for more organization, and then paste in that block. So we'll say artist, name, and then all the tests. So you can imagine like we'll have another describe block for another attribute for artist if it had one that also had validation rules. So if we're to run this, you can see it's just nested a little bit more and gives a little bit more organization. Okay, so I think we're at a good point. Let's we'll just kind of finish with our test. Generally, you want to have pretty good test coverage that covers like all code paths. So yeah, if you're adding new code, make sure you kind of have tests. And but let's hook this up with Travis CI. Yeah, sure. Okay, so we're going to hook this up with Travis CI. So again, continuous integration is having something in place so that you remotely run all the tests and verify that all the tests currently work before taking your code and putting it inside the master branch or your like main branch that gets shipped to production. And so really useful workflow for if you're working on a team and you have multiple people like contributing code. Imagine like one of your teammates, he adds a little piece of code and you add a piece of code, and what if like that person broke something that you were working on? Like you would want to know about it, right? Especially if people are like touching the same files and everything. You could easily just run into those situations where like one person breaks something and then it gets shipped. So how do you like verify all that? You could have a QA team that just manually checks everything every time there's a change, but you can see just having these tests in place will automatically it gives a pretty good indicator if something was broken as new code was being added to the project or code was changed. So it's a good practice just to kind of always have tests that do pretty good amount of coverage for all your code. You can't really have like continuous integration without tests. It doesn't really make sense. So yeah. So testing is just kind of like one of those good practices. Especially in particular for projects where you have lots more. It's more than you just working on it. If you're just working on your own side project, you can probably get away with it, just without tests, just depending if it's a small project and you're the only one working on it, so no one else is touching the code and you're just manually testing things, you might, be okay. But as it grows in complexity and it gets bigger and bigger, it's nice having an automated way to check everything. Like right now, even like my app at work, it's, takes 15 minutes to run the entire test suite, but like that's infinitely a lot faster than having a QA team like go through every screen and check things, especially when you're like, if I update libraries or libraries could have, could have breaking changes. So if I were to upgrade from like Ember 2 to Ember 3, right, there could be some breaking changes there, and I don't really know. And so being able to have these tests to say, oh, do they still run? And it gives a pretty good indicator, especially if you have tests that cover most of your code paths. It gives you a good idea if everything is still working. So we're going to use Travis CI. It has a free plan, which is nice. So it works well with GitHub repositories that are public. And you can also have like a private instance, which Travis also works with. But for free, it's really nice. And you'd see most open source projects actually leveraging it. So if I were to go to like Ember GitHub, and if I were to just look at kind of like the Ember project on GitHub, you'll see like these badges on a lot of repos, these like right here, build passing. If you actually click on this, it'll take you to Travis CI, and it'll say like, show you the builds every time like code was being changed and merged and all that. So you can see like right now it's running. So Travis is a really good option for your projects. Some other options are Jenkins, Circle CI, Hudson. There's probably more. I just can't think of them. Whoops. Okay, so to enable Travis CI, you're going to want to do a few things. So let me close these links. Okay, so you want to go to travisci.com. Oh, travis-ci.com. And say sign in with GitHub. And I think if you go to dashboard, why am I seeing everybody's stuff? Wait, who am I going? Oh, maybe it's .org. That's weird. Yeah, okay. So click on the plus sign. So my repositories, plus, and you should see a list of repositories. If you don't, click on sync account, and this will kind of fetch all your repos from GitHub and list them here, so you can turn it on for a specific repo. So you select just specific ones.
I've never used this.
Okay. Like, are you on this screen?
No.
Okay. Well, I guess get to this screen. Yeah. Oh, yeah. Sign in with GitHub and then click on the plus.
And then I have another.
And you're at travisci.org. Did anybody else seeing this? If you click plus, do you get like something like this? Yeah? Okay. Oh, okay. I don't, it's weird. Okay. Yeah, click syncing or sync from GitHub. and then you should be able to find your repo and then just click that switch. So mine's, because this repo for me is in an organization, I just kind of separate each class by a GitHub organization. Mine's here. And I actually, let's see, SQL. I did this yesterday, so my switch is already turned on, but turn yours on. Oh, wait, okay, so who cloned the repo, my repo?
I was just gonna ask about that. It's like my basic understanding.
Okay. Okay, so what you're gonna have to do is, for the people who cloned my repo, you're gonna have, if you do like ls-a, you're gonna see a .git file in or folder in there, and that's basically your Git repository, and it's tied to my account. So if you try and like do git push, it's gonna try and push it to mine, but it's gonna fail because you don't have authorization to do that. So what you're gonna have to do is type in this command, rm space -rf .git, and what this means is it's kind of a very destructive command, so you want to be careful with it. So like type these two commands, but like you should see this .git folder here, and so if you see that, run this. I'm not going to do that, but it will essentially delete this folder. And then really, like, if you had hidden folders showing on your computer, you could just navigate to the folder, right click, and delete. But given that files like aren't like folders that are hidden or start with a dot or a period, they don't show up like in your Finder window on Mac. At least you can't really easily do that. So this is like the way of deleting things from the command line. Well, you can actually just say, so if you're deleting single files, you can say rm and the file name. But with folders, you have to say rm-rf.git. And what the R and the F stand for means recursive. So that means like inside the Git folder, there's going to be subfolders. So go through every like subdirectory within .git and delete it. And then the F means force. So without F, it's going to say, are you sure you want to delete this file? And then you say yes. Are you sure you want to delete this file? And you say yes. So you have to, like, it's kind of annoying. So the force will just say yes to all of them and force delete every folder and file within .git. So that's hence why it's like destructive. So you want to be careful. Like don't delete, I don't know, like your home folder on your computer. Then you're like, I don't know how to get that back. Yeah. Yeah, then you probably have to reformat your Mac at that point. So yeah, deleting that Git folder, you'll be able to disassociate like what you cloned from my account. So at this point, then do the whole like git init, git status, create the repo, and then push it up to GitHub. So I'll let you do that for those who cloned my repository. So push it up to GitHub, and then at that point, then just resync the account, and you should see it show up here like once it's on GitHub. So it'll just take like 3-4 minutes to do that. Which one do you want? The remove? And if you don't have it, then you're good. Or if you already were using like your own project or whatever then you're fine. So just to kind of show you an example of like the workflow is, so you have like your master branch on GitHub, and you have different people working on your team. They want to commit code to this master branch. They create what's called a pull request. So a pull request is like saying, I want to request my code to be pulled into the master branch. And so everyone, you're going to have probably like somebody, like a project manager, will assign you a ticket that says, create the listing page for users, right? So you'll create a ticket, or you'll create another branch in Git that says create users. And then you'll push out that code under a branch name maybe called create users. And then you're going to create what's called a pull request to merge in that create users branch into the masters branch. And what that pull request would look like on GitHub is, I kind of created one for the same repo just as I was prepping. And if I click on this, you can see all of the files that are being changed or added. So you can see pretty much just all additions here because I was just adding a bunch of tests. But if you would see changes, you would see those as well. And you can see it ran the Travis CI tests. And if I were to click on details, well, you can see every commit that I made in this pull request. And you can see the green checks are the ones that failed, and the ones that are X'd are red, meaning it failed. And if I click on to the details right here, you can actually see an output of me running all the tests. So this is like that output that I would see, just me running it via terminal. So pass, so it's all good. And I was just kind of purposely failing them just to make sure, like, hey, does this work? So if everything's good, then you can say merge this, and this will get put into the master branch. You can see I want to merge 7 commits from master into master from the test branch. So I'm not going to merge this one because I'm going to create another pull request that does that. But that's essentially what a pull request is. And this is a pretty common workflow. You'll just see this in a lot of like software development teams. Yeah, if everybody just commits the master, then it just like, one, it's not running the test, so somebody could break something before, and it could get into master, which generally means like, hey, this thing's ready to go into production. That's no good. So this is a pretty common and good workflow to make sure master stays passing and clean. And this also gives a chance for people like on your team to review it. So you can say, they have some built-in features in here. So you can say, oh, here it is, see like review changes. So my teammates will see this. They can comment on specific files. They're like, hey, don't do this or whatever. Okay, so let's see. So going back to Travis, I said I turned the button on. And if I go to settings, so click on that settings tab. I'll actually go back. But here's my SQLized class repository. If I click on settings right here on the right next to the switch, after it's been turned on, I'll click on this. And I'm going to say build pushed pull request. So I don't need to push every single branch that I make up and go up to GitHub. I just want to build the pull request. What this means is if I were to create a branch and just push it on up to GitHub, that means it's going to run the test. But like sometimes I might push up a branch and I'm not ready to kind of make that pull request. Like for example, I might be like half done with my ticket and I'm going to push it up to GitHub just to say like, if my computer crashes, like I can pull it down from anywhere. At least it's like safely there. But I don't want to run the test if it's like half finished. So, I'm saying turn this one off. Oh, whoops. Yeah. And that should really be it, just to like use the Travis CI to hook it up with your GitHub repository. Okay, so going back to my command line, there's a couple things we need to create. Well, the first thing I'm going to do, I'm going to check out a new branch called test class, just to differentiate from like my prep stuff. So -b stands for branch. I want to create a new branch. It's called test class. So I'm not going to commit this directly to master. I'm going to create like a separate fork of this. And once this is all good and Travis CI verifies test branch is passing and my teammates have reviewed it, then we'll merge it into master. Okay, so the first file that I need to create is one called .travis.yml. And this is a configuration file specifically for Travis. And this will allow me to say what version of Node do I want to use, or which test command do I want to run, those kinds of things. And the YML stands for YAML. There's like another format called YAML. It's kind of like an indented base configuration format. So you got like JSON, you got YAML, those are probably XML. Okay, so the touch command just created that file in my project. So if I were to open this up, you can see here's this Travis YAML. All right, so I'm going to paste in a few things here. So language, I'm going to say node_js. So it follows this format of like key, :value. I'm going to say node_js and then 10, so meaning version 10. And then the script that I want to run is npm test. And when I push this up actually to Travis, like we've ignored, or let's see, did we? Yeah, we created a git ignore file, right, that excludes the node modules directory. And that's because we don't want to make our repository big. We don't need to include node modules. Anybody who clones this can just run npm install, get all those packages, and everything should be good. So we need to tell Travis to run npm install. So there's another key that's before, or actually, sorry, install. And we can say npm install. So it's going to run this to install, then it's going to run npm test. Okay, so there's one other issue that we have to deal with. And if we look at our test right now, we've written in and it's all cool, right? But then we have a problem where, like, locally we created a separate tab to run the server, right? So we ran nodemon app.js and it was fine. And that gets it working, so my API test can make those requests to the endpoint. But when it's on Travis, how do I kind of like set up another tab to boot up the server? So I need to like do this. And there's a nice tool for doing this called Forever. Let's see, where is it? So I put a link to it right here, Forever. And it's like a node package that allows you to run the node server like in the background, right? So if I look at this tab right here, it's like hanging, right? It's just waiting for requests. But I could actually run this in the background through this Forever library. So just to see what this looks like locally, I'm going to kill the server, and I'm going to install Forever. So I'm going to say npm install -g forever. There's a few different libraries for doing this. This just happened to be a popular one. And the way this works is instead of saying like node or nodemon app.js, I can say forever app.js. And if I run this, oh, whoops. forever start app.js. And you notice that it gave me back control to the command line. So it's not like hanging there. So it's running in the background. So if I actually navigate to localhost / 8000, let's see, what's one of the endpoints?
I forever think it work.
Okay, 1 second. Okay, playlist. Let's do this one. API/playlist. You can see that it's still serving requests because forever is running. So now if I run forever stop app.js, this will pull it down. If I refresh, yeah, see, site can't be reached. Oh, I think I know what it is. Okay, so npm install -g. Okay, so if installing forever didn't work, I think run sudo npm install -g forever. Yeah.
How do you get it so then, like your test class and then the master branch, like that shows?
Oh.
Like when you're on master, it says master.
Oh yeah. Let's go over that at the end. We'll touch the bash profile and we can do that. Yeah. So did that fix it?
Yeah.
Yeah. Okay. Cool. Okay. So the forever package allows us to kind of run the server in the background, which is so that we don't have to like have a separate tab or whatever. So what we're gonna do is we're gonna modify our script. So instead of running, well, the first thing that we're gonna do is say forever start app.js. So we're just gonna put a series of commands and we separate each one by a semicolon. So we're gonna start up the server, then we're gonna run Jest to kind of run all of our tests. And then at the end, we'll say forever stop app.js. And we'll save it. So let's check to see if this runs locally. So I have the server turned off. Now if I just run npm test, it's going to do the forever thing. It's going to run the test. It'll stop the forever thing. And you can see kind of forever being logged to the console and all that. So, so this is working locally. So now that we figured out like the separate tab issue, we can go back to the Travis YAML. And there's another like hook that we can say before script : and so we need to tell Travis to install that forever, right? Because we installed it globally in our machine, so we need to tell them to also install it globally. So we'll say npm install -g forever. Yeah, one of the nice things about like maybe some other tools, they just kind of come pre-installed with the Travis YAML file, so you don't have to like figure out what these are. The only reason I kind of knew these is like, I've worked in other projects that just had this already, installed by default, so I didn't have to think about it. So I just copied it and just modified it here and there. So like more complete maybe frameworks would probably have this, so you don't have to kind of set this up already. I imagine like Laravel does, Ember definitely does. There's some other node-based frameworks that I imagine that are more like full stack, I guess, here, or like more batteries included approach. Cool. Okay, so let's check to see if this all works. So we got the configuration. What I'm going to do is I'm going to, let's see, clear. So if I say git status, here are all my files. I'm going to say git add all. So I'll say git status. So I'm about to add all of these new files. I'll say git commit, add a bunch of tests, and set up Travis CI. So I'll make a commit, and I'll say git push origin test - class. So this will push it up to GitHub. And if I browse to my repository, kind of if you go to the home page of the repository, you'll see that GitHub automatically detects when new branches have been pushed to it. So it says less than a minute ago, so I can say compare and pull request. So I'll just click that, and it already sets up saying I want to make this pull request into master. That's generally the convention. And I'll say create pull request. So now, hopefully at this point, you should see a yellow dot, meaning it's processing. And you can like right now I can say merge pull request, and I can click this button and it'll automatically merge it, but you can actually set it up to say like disable this button until they all pass. So you can like be really strict in the settings on GitHub, which is kind of nice. And you can even do things like say the tests have to pass and you have to have a review on the pull request. So making sure that people just don't like make the pull request and review automatically without a review, or merge automatically. So yes.
Can you go to the compose file?
This one?
So compose package.
Oh yeah, here, let me paste this in the Slack. So you can actually just click into Travis, and if I were to click on details and watch this, you can just watch the output in the Travis console. So you can see here I did like npm install -g forever, npm test, pass, exited with 0. It'll turn green, meaning it passed. So if I go back to my PR, just give it a minute and it'll kind of resync back up. Or looks like it actually turned green, but then this one, so maybe it's GitHub didn't pick it up or whatever, but sometimes just refreshing, you'll see it turn into a check. And so that's, yeah, CI. So there's one other thing that I think is useful, and it was kind of when I showed you if I went to like Ember.js GitHub, and I clicked on the repo, you saw that there was a badge at the top, right? So I go to the repo homepage, there's this file down here, and it shows like this little badge. This is a Travis CI badge, so we can add this to our project as well. And so this is their readme.md file. So we'll go to our project, and let's create the readme. So I'll say touch readme.md. So we're just going to create this markdown. We'll go back to our code. We'll open this up. And you can get access to that badge by, let me close this. If you go to the Travis CI page for this repo, and you click on the badge up here where it says build unknown, or it might say like passing or whatever, but if I click on this and choose markdown for the master branch, I can just copy out, this is just some markdown code, and this will create the badge for me. So branch, markdown, copy this, go to my readme, paste it, and now I'll just push this up. So I'll say Git status. I'll say git add all. Git status. Git commit. I'll say adds Travis CI badge. And then I'll push this up. Or git push origin test class. So I made another change. If I were to go back to my pull request, you can see that it's running again. So every commit to that PR, it's going to rerun the test again. I think if you were to look at, let's see, files changed. Oh, here it is, README. But yeah, once this merges to master and we view this, then you'll see that green badge on the README. Oh, let's see, did it pass already? That's still going. Okay, so now let me go back and uncomment some of these other tests. Let's see, was it this one? Okay, so it's kind of nice because now I can just run npm test. I'm running the same thing Travis is running. I can just test this and make sure, like, is everything cool? I remember when I prepped this, it was all working, so maybe I forget it. Maybe the forever thing did something. I forget exactly, but yeah, see, it's passing. What was the? I forget exactly what the edge case was. Okay. Well, now that the infrastructure is kind of in place, you can go back and, let's see, kind of add these tests back. So uncomment them, we'll test it. If I run this a few times locally, yeah, see, everything's passing okay. So I forget exactly what the edge case was, but ideally it would be nice just to have the, the same database instance for every single test, but yeah, that would require more like setup work. Okay, so given that those two tests are okay, given our new infrastructure changes, we'll say git status. Okay, so I wouldn't want to commit the database change. Oh, okay, so another thing that we could do is kind of modify our command just so that we don't accidentally commit our database changes. So we can go back to the package JSON, and after every single test, let's just reset the database. We'll recheck it out. This way we don't like automatically or accidentally add it and then push it up. So I run git, or not git status, npm test. Okay, so git status. We won't accidentally commit the database. So I'll push this up. So I'll say git add all, git commit. So we'll say adds back, post, and delete tests. And I'll say git push origin test class. And it's going to kick in again. Yes.
Remove git checkout commit from the beginning of that line, or is it not still on the line? Oh, okay.
Yeah, I just copied it to the end. Yeah. I think the way Laravel does it is like they'll create the SQLite database, but there's a way to do it in memory, and then it runs all the Laravel migrations. So it like creates the tables and all that, and then you can seed it with data through Laravel migrations. But we also don't have migrations here, so that's another thing you'd have to like set up. So yeah, this is probably the simplest for what we have without having to spend too much time on that infrastructure. Okay, so going through some of the resources, I'm going to close all these. You can check out the Frisby docs. I mean, they go through a lot of different like assertion types, or how would you make different request methods like post, patch, with some examples. So really good docs. This is one of the better ones I found with docs, so that's why I chose it. The Jest testing framework. So those functions like describe and it, that's coming from Jest. So Jest is running it and then taking those functions that we wrote and kind of running each test. So you can learn about it. Jest is also used for testing, like, so we did it in Node, but you can use it for like, I think it's pretty popular in the React community. It looks like Angular and Vue as well. So, you can use these Jest tests for front-end code too. There's a bunch of other things, but that was just kind of like basic usage. You can look more about the chai assertion library. So we covered, if you look at, let's see. So if you click on API, chai comes with like a few different flavors of assertions. We're using the expect one, so that's why we wrote functions like expect something to equal this thing. But there's also another style called assert, so you can write it a little bit differently. I think it comes down to personal preference, so which one you like to use. I think the expect should style is probably the more popular one, but it has another flavor of it, so that's that. So I just put a link to travisci.org, so not .com. I also put a link to Travis CI core concepts for beginners. It just kind of goes over some notes again for like what is CI and like describing kind of that workflow we went over and building, testing, deploying, just like information about it. A link to that forever command line utility. And okay, and then let's go over the assignment. So this is actually the last assignment, not the last lab, but the last assignment. We'll have one more lab, and that should be it. So for this assignment, you're going to do some testing and hook it up with Travis CI for your Sequelize ORM lab. You're going to do it for the patch request. So if you go back to that Sequelize ORM lab, you made a patch endpoint for creating a track, and updating a track. And you'll write a few tests, so a few API tests for the case for when the track doesn't exist, one for when you update a track successfully, another one for the validation errors. So if you try and update a track and it fails validation, you'll get back some errors, so assert against those errors. And I gave you the example request payload, so like name is required, so that will fail. Milliseconds has to be a number, and I made it the letter A, so that will fail. And unit price also has to be a number, so it's letter B, which should make it fail. So use this as the request body. And then you also write a few unit tests for the milliseconds attribute validation rules. So these have to be unique, numeric. And you'll have one that verifies, hey, it's not when it's not numeric, it fails. If it is numeric, it passes. You'll hook it up with Travis CI and make a pull request, and then send that email to me and Finn with a link to the PR. Oh, and you also have the Travis CI badge. Any questions? Due next week. Yeah, let me update that right now so anybody doesn't say. What's the date next week? Oh, let's see, 4/9, I think. Okay, so make sure for the lab on the research on like relational versus non-relational databases, that should be done before class next week. So no extensions on that, just because it's kind of prepping for the guest speaker. Some other words, so you can like Google around for relational versus non-relational database or SQL versus NoSQL database. Those are kind of used interchangeably. So, do a little bit of research on the different types. And I think that should be it. Any last questions? Cool. We'll end it for